Okay, so in this video I'm going to explain how to make a Connect-4 using KorGE. I'm going to do this session in Spanish this Saturday, but first I want to do it without any time restrictions, so I can figure out how to do it and how to do it in 1 hour and 1 hour or something. So, well, first of all, the Connect-4 is this game. This game is like a board of 7 columns per 1, 2, 3, 4, 5, 6 rows. So there are two kinds of chips. Ones are yellow and the others are red. And you have to put a chip in any of these columns, and using the gravity that chip falls like this. And the objective of the game, there are two players, and one player have the red chips and the other one have the yellow ones, and what you have to achieve is to connect either vertically, horizontally or diagonally 4 chips of your color to win the game. So these are the rules for this game, and well, I have two options to create this. I'm going to do a simple approach, so I won't do anything fancy here. I will try to make this game, I will create this game using TDD, so I will start creating the tests, and I will ensure this is testable. So regarding to the graphics, I can do 2 different approaches. I could try to make the graphics programmatically, or using a graphic program like Krita or GIMP or something like that. So well, I will probably first try to do it programmatically, and if that doesn't work or it's too complicated, I will provide the graphics directly. So the hard thing here will be doing the holes here. I think we can do it already with the graphics, with the Vector Graphics API, but I'm not sure, and I don't know if we support removing shapes in all the targets. So well, let's get started. First I'm going to create a new KorGE project like this, and I'm going to put this here, Connect-4, and well, the first thing I'm going to do, so this is not working. Oh, so this is broken right now. Nice. It's a good thing I found this now and not this Saturday, and maybe other people is facing this issue. So I think we have to update the IntelliJ plugin, KorGE IntelliJ plugin. Here we have an XML file, this one I think, this one, and probably it's something like this or so, what's causing problems, but I thought I'd try this, but maybe not. In fact, here it is hard-coded, so well, I don't know. I will check this in other moment, but I think this should be something like, let's force it now so I know this works for sure. Something like this, I think. So I think the plugin checks. Let me remove the folder. Connect-4. Let me remove this and let me refresh. I'm not sure if this is working on, or if I have to wait 1 day or something. Let's try. If not, I will use, if this doesn't work, I will use the KorGE template instead. No, this was not updated. Well, then I'm going to use the KorGE Hello World template from KorLibs, KorGE Hello World, and I will check this later. So this is the Hello World. Let me copy this. Maybe this from here to maybe here. So this is the Hello World. I guess I have to import the Gradle. Maybe I have to reopen this project. It is a pity that the plugin was not working. Maybe this have GitHub actions, so we should try that we should check that part works as expected. So I will do that in a separate video, but for now let me import this Gradle project. and hopefully this let's starting here our tests. So while this is indexing, but I would like to run this first to be sure this works. In fact, it's not the case. Why? Because of the package. So main KT, So yeah, so here's the hello world, but I'm not going to start with graphical stuff, but we should implement first the logic of the game. Logic test. So maybe the model test. So what we are going to do is, since this is a board game that also works in turns, we can represent this as a board and a set of transformations. For example, operation as a set of operations. So the board applying an operation has as a result another board and a set of transitions or something. So for example, if in this case, if I have a board that it's empty and I perform the operation of placing or dropping a red chip in the last column, that will result in a new board that is not empty anymore but has a red chip in the bottom right corner of the board, and the transition will be to place a chip there in that column, so we can later update visually. We can use these transitions to update our views. So well, the first thing we have to do is to figure out a way to represent boards here. So I have been thinking about this, and maybe we can do something like this: 1, 2, 3, 4, 5, 6, 7 columns by 2, 3, 4, 5, 6 rows. So maybe we can represent the board like this. So this is an empty board, and maybe we can represent chips like this. So one of these is red and the other is yellow. So well, actually, if we have this initial board and the end board, start board, or I don't know, if we have this and we perform an operation like operation dot place chip red in the column 7, for example, or 6 if we take 0 into account, chip. So maybe with this applying to the start board applying this operation and getting the new board, we should get the end board. So maybe something like this. This is testable, and well, this is the expect. So yeah, maybe we can inline this here and maybe do the same here. well, we should expect this board starting from this one and applying this operation. So something like this, I think, could work. Yeah, so let's start with by creating a board. So maybe lines or rows, a string with a list or something like that. and well, starting with this, we can provide a bars rows string here and call the constructor with a list. So with this we would have a board already, nothing too fancy. And well, this is immutable, so this board is immutable already, and maybe we can represent the operations as a shield class and place class with operation that requires a chip and a chip, the chip and the column that is an integer. So I usually like to use shield classes here, so we can place several operations, but when checking which operation are we performing, we have to be exhaustive with every check here. So well, the chip could be an enum like red and yellow, and maybe empty or no chip or empty. So yeah, also maybe I should start making this more simple, but well, let's do like this. So the board has an apply method that should return a board result or something like that, or board transition, I don't know, with the new board, and later we will add transitions or something like that. So this should return this, and well, let's not implement this for now. So we have the board, we have operations we can perform, and a set of chips. So well, let's try to run this. So we in TDD we start with cases that fail. In this case fails because it's not implemented, so we can try to perform the operation here. So here I'm going to create an operation to set row, column, and row maybe width, since we are not mutating this both, to allow to set a chip maybe here we can specify a character here like this. The character that we are going to place here, we can specify it like this. So here we are going to return a new board, changing that. So I think what I'm going to do is to create a new board here, and I'm going to map all the rows here. This is the row. Maybe map index it so I have the row number and the row itself. And here maybe what I can do is to convert this row into a chart array. And then this is a copy, so I can mutate it, row charts, and maybe in later I can create a new string from these charts, so I'm able to mutate it. So for example, here I can use the column when the row is the row, well actually row string like this. So when the row I'm in is the row I want to update, I'm going to update this char array with the column, and I'm going to place the chip character here. So yeah, something like this. So let's see. Our first approach doing TDD will be to place the chip in the bottommost in the bottommost place of the board. So for example, let's get from this operation, let's first check which operation is this. Is this an operation place? Right now it's going to be, but we have to check. So this we perform a smart cast here, and we have access to these properties here. So I'm going to get a new board using this method. So I'm going to use the column that has been provided here, and the row is going to be 5, I think, since we are using 0 indexes. So 0, 1, 2, 3, 4, 5. So in the 5 column, I'm going to place the chip that they instructed us to do, and I'm going to return a board result like this, and let's see if the test passes. Yeah, now the test passes. Let's return our own board so we can see this doesn't work, and maybe we can represent the board differently, so it's easier for us to see the difference. Maybe we can convert this into a string separated by line returns. So here we can see the difference more visually. So we expected to have an O here, but we had an empty cell. So well, since we did this, let's use it. Well, this test is passing, but what happens now if we try to place from this board? What happens if we try to place now a yellow chip? What happens? So let's run the test, and what happens here is that since we hard coded the row, now this is replacing the old chip, and this is not what we want. We want to place that in above this chip. So we should probably need an operation to know the height of this column, so we can remove the height of the column from it. So initially let's do something like this. Initially it could be 0, so this test continues passing, but we should compute the right value here. We should need an operation to get the chip from value here. So we get the chip, we can get the chip here, and what we can do here is to get the rows, this list, and get the actual row, and then get the actual column. Since this is a string, we have to convert the character into an actual chip. So for now, well, let's do it right. It should be something like, let's create a map here with the values. These values is a list of chips, and we can associate this is indexing, probably an error since I'm using an experimental version of the IDE, so there was an error and it's trying to reindex. But well, I can associate it by the character. So this creates a map associate by, I think. So this creates a map from character to these chips. So here we can do something like map, and this would return a chip or a null. So let's use an empty here when we get a null, and well, this way we should be able to get what's in a chip. Let's try it. For example, in this column, let's get the value from the last row chip and the previous one, and let's put a breakpoint here, and let's run this test. So yeah, maybe we should actually create a test for this. So let me add it. So from a board like this, so from from this board, okay, so board, so from this one, if I get board column 0, row 0, this should be the yellow chip, and this should be an empty cell, this should be an empty cell too, and this should be the red. Okay, so test get board get. So here this test is passing. Doing TDD, I should have created this before, but well, let's not be that strict. So well, what we are going to do is we can get the height of or maybe the num rows with row size, and the num calls from the first one length, since this is a string. So what we can do is to iterate over all these rows. So we can start here and check one by one when it starts to be an empty cell. So we use that number to return the height of this column. So if I start here, I iterate over all the rows, and then I try to get the chip in this column at that position, starting from the last one. In fact, we should do this so we can operate with other board sizes. And if this is an empty chip, we are going to return this n. And if we don't get any empty chip, let's return the height should be this num row. So something like this. I could have performed this in another way, but well, this is not required. And what happens here, if we try to place a chip in a board, in a column, in a board that is already filled, already complete. So what should happen here? So what in this case, sorry about my dog. In this case, we should, this yellow is x, let's put red instead. But I thought this was going to nothing is placed, but since this is not showing anything, but the row here is probably -1. So, well, what we want to know, we want to know if this is a valid operation or not. Maybe what we can do is to make this nullable, so the board operation can be null. Then we can try to get the board like this. So if this operation is invalid, maybe we should return, let's use num rows -1 here, num rows and num calls here. Yeah, let's check, let's place, let's extract this into a local refactor, introduce variable, and the 8 here, and if the 8 here is equal or higher than the num rows, this operation is invalid. Let's return null. So here we have a null instead of an actual board. So here we should put null, and this test is test invalid placement, test place over another chip, and test place on empty board. We could add a lot of tests here, but I'm not going to do that. Let me launch these tests, and well, we have something like this. We should do the same here. If the column is not in the range of 0 until null columns, why is this not working? 0 return null. Why is not this is not working? It should. This is a range. Num calls. I missed something here. So wait. What? Is sorry, it's not is. Yeah, it's not working because I misspelled this. This is in until this, so something like this. Let's use this board here, and let's create a couple of assertions. So something like, yeah, if I place in -1, this is null too, or should be char at yeah, I have to compute, I have to check this before I actually try to get the 8, and the same happens if I try to use another one like this. Okay, so yeah, like this, we can figure out if this operation is valid. So we can try to get a list of valid operations, get available operations, so we can, so later we can allow the user to perform them or not just the user, but we can do the same for the matching in order to create a bot. So we could so we can with this list of operations we can perform a lot of things here. So, or maybe get available lines, well, columns. Well, let's specify the chip, since we are not taking into account tones right now. So, well, what we can do here is to try to apply to create all the possible operations, like place this chip in all the columns, like this, and operation, and check if this operation is valid by applying it. So it is valid if applying it doesn't return null. So in this way we can out this list of operations here, something like this. Okay, and this is a map filter. This is a map filter like this. So here we can get a list of available operations. So test available operations. So in an empty board, if I try to get the available operations from this board for the chip yellow, the operations I will get will be, maybe I can store these boards like board with full last column here, and so I can reuse it in several tests, since I'm doing normal tests here instead of using another framework to support nested tests. So like this, I'm going to map these to get this to be filter instance of operation place, and I'm going to get the column. So I'm here, I will just check which columns are available. So in this case the available columns should be 1, 2, 3, 4, 5. So 0, something like this should be. Sorry, something like this. And for an empty board, empty vote should include the sixth column, the sixth column 2, board empty. So yeah, something like this. So with the available operations, we can maybe indicate the user where that person can place the chip. So yeah, another thing we should know is whether the game has been completed. So someone has win, or it's a tie, or something like that. So let's use a chip as a result to see if the result of a game. So if we return red, the red has win. If not, the yellow. If it's empty, if this an empty chip, it's a tie. And if we return a null, the game has not been completed. So let's create a function called, for example, let's do this using TDD, test winner. So for a board empty, this should be null, but let's create several boards here. Board win yellow. Maybe I should use R and yellow instead of X and O. Let's do that. Since X was yellow, X was yellow, X was yellow, X was yellow, and O was red. So yellow, red, yellow, red, 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 red. Okay, so for win red, for example, like this, or maybe we can start with this instead. What win red? So board win red should be chip red. Board tie, board full, and it's tie. So let's create something like this. So here I think this is tie, because I can see in the vertical we don't have any match, anything matching for in the horizontal either, and I think we don't have the possibility to in diagonal too. So in this case the winner should be the winner should be empty. So this is a tie, and well, we are now have passed 50 minutes, so I will have to make this quicker in later. So well, we should split these assertions in several places, but well, let's do this like this to be faster. So the winner can be null, and here let's create a board is full method that tells us if the board is full. So the board is full if all the columns if the eighth of all the columns, so num columns, see if the eighth of all the columns is the number of rows. So when this happens, the board is full. Let's check this. Test board is full. So the board is full for an empty board. This is not true, but for this board is true, and for other boards like this one is false, and this one, this should be false. So let's try this. Let's not implement this now. So full tie, so this not working here. Let's try to figure out why this was not true. So let's run this here, and let's try this. So the eighth of it, well, maybe I'm not inside the lambda. So well, let's do this manually with a for, so it's easier to test. It's easier to put breakpoints here, but rows, if we are in a column, let's return false. Maybe we can put this here, and this is I was using O instead of yellow, so maybe here probably if we are, instead of returning an empty chip, let's throw an exception with invalid character C, so we can, so we know we have an invalid character here. So O's were yellow, like this, and now let's check. Here we have to return true, and yeah, I think that we can do this. All 8 it equals num rows, so something like this, and now we can enable all the things here and try all the tests. So yeah, now we can try to implement the winner. So we should try we are going to do this slow, but we are not going to optimize this, since this is a very simple game that won't have performance issues on any platform. So let's not optimize this, and let's make this simple. So let's iterate over a list of chips, chip red and chip yellow, or maybe, well, let's do this, and maybe what we can do is to return for invalid positions. Let's figure out when it's valid. Let's figure out when a position is valid. So it's valid if the column is in this range, num until num calls, and the row is in this range. So if we are not in a valid position, let's return an empty chip. So here we can perform we can make everything simpler, so we don't have to figure out valid ranges to not perform invalid operations. So here let's iterate over the whole board the whole board, like num the num rows, and call num columns. And for each cell we are going to, for example, for this cell we are going to check if we are matching these ones or these ones or the diagonal ones. Since we can access out of bounds cells, we should be able to, we won't have to take care of things like this. So let's make an operation that checks a column and a row, and with a directional vector. So for example, +1 will check +1 here, and 0 here would check the horizontal ones in this direction. So we are going to check if all the chips, in this direction matches the one in this position. So let's make 4 iterations starting on 1, so 3 operations, and the column is the X, so, and the row is the Y. So if any of them matches the original chip, let's return null, and if they matches, let's return this chip. So yeah, like this we can try to check this column and this row horizontally, vertically, and in diagonal, these 2 diagonals, upwards and downwards. So I think let me check. For example, this we would match this one. We would match this one in this point downwards. So we only need these checks. So chip 1, chip 2, and chip 4. We don't need this anymore. So yeah, if any of these chips is red or yellow, we have a winner. So, and actually we can let them know. We can create a win result that not only specifies the chip that won, but also the chips, the positions. Maybe well, let's use point from KorGE. Point from KorGE. So, or maybe a pair of ints with the column and position. Okay, so column and row. So this is clear. So here we can provide a result like this. So column here, column and row, and we can create a list of positions here. So we can provide them here, column and row. So the chip is this one and the list is this one. So this also works for empty. So in empty, let's not well, if the chips is empty, we can return here. So yeah, in this case this will only work for red and yellow. So if we have a win result, actually this is a win. So win, or well, win 0, win 1, win 2, and win 3. So if win 0 is not null, let's return it. Do the same with the other ones. And now here, instead of returning the chip, we are returning a win result. And well, if we couldn't find any result, we have two options. If the board is full, this is a tie, so let's return an empty, something empty here, and if not, the game is not completed. Let's return null, and yeah, something like this. Here you can check the chip instead of the winner result, and let's try to run this. Yeah, it works. And maybe we can also check the list of positions here. So this is a data class. So here actually I'm missing the original position, this one. Maybe not even required. If I start here, this will perform another operation, but it's okay. So now I have this position 2. So this is in the last row and the left part of the board. So let's check this. Yeah, this is the case. So well, with this I think we have already completed the modeling this game, modeling the game logic and operations. And I think here, when performing the operation in the board result, we should somehow support the winner. We can provide here a list of actions, or I don't know how to call this, but something that can be executed by the views when rendering. So yeah, something like place a chip or drop a chip in a column and a row. So we know, so we with the result, if we have the previous board and the new board, well, we could check what changed it, but if they tell us what changed it, it's easier. it's easier for the view to instead of just updating the views and placing the new, if we place several, if we have a list of actions to perform, we can do the animation. Yeah, we have this previous board and these actions, so we have an action that drops a chip in this column up to this row. Well, with that it's easier. Chip, so this is an action, and we also have an action that is win or finish the game with a win result here. So well, when applying a transformation here, we can, in addition to this new word, we should have a list of actions like this. Okay, so if the new word is have a winner, if the winner is not known, let's create an action for finishing the game with the winner. And if since we are placing a chip here, let's create an action of dropping a chip in this column and this row with the chip they provide us. So with this chip. Okay, so well, this is a bit messy. Let's try to improve this. We have a build list here, so we can somehow do this, and we can place this here with actions and the code. This is experimental. Well, actually we can do this like this also. So well, something like this. Also, I think we can do this. So well, in every operations we will have a drop action, and in some cases we will have a win action. So well, we should test this doing TDD, but well, you know how it works, and I want to be faster here, so we don't run out of time here. Well, I used this same file both for the tests and the model to be faster writing this, but now it's time to move these classes to its own file, model own file, or several files as you want. But well, I'm going to move all the classes here for now, and we have two parts. We have the actions. the input is the board and operations. This is the input, and this part is the output. R is the board result and the list of actions. So yeah. Okay, so now let's try to render this. I'm going to create, well, let's start simple, and let's start with an empty board. Let me create an empty board here as a companion object. We should this is our standard empty board, this one. So let's move this to a package, Connect-4, so we can import everything. We can import in the tests Connect-4. So Connect-4 and Connect-4, and here I will probably have to set the class, the VM main class name to Connect-4 main KT. So, well, let's start with an empty board. We are going to have a local or property with the board. This is immutable, remember, so we have to mutate the current board. So let's create a function to let's create we will need the graphics for this. So I'm going to use chips that are 64 by 64 pixels width and height. So the board should be 64 by 7 and 64 by 6, the standard one. And let me compute this 60 by 6. So with this width and height, we should have the full board here. Let's start creating the programmatically the chips. And I'm going to create something like this, context 2D, and I'm going to draw a circle, fill 1, colors red. This is going to be the red chip. Let's fill this and a circle that starts here and that has something like this for the width. We have to include this. So let's place this image to see how it looks like. Not this, but run JVM. Connect-4. I think I missed an N here. Connect-4. Okay, so yeah, something like this. So this is the chip. It has some spaces between, and well, let's not draw the case of the game. so it is simpler. Maybe we should do the same for the yellow chip here. And well, maybe, well, let's have an empty chip here too. Empty chip. And well, let's see if we can draw the skeleton of this. That maybe, let me check, maybe skeleton, maybe if we draw as a rect here, and I don't know the inner, oh yeah, it worked like it directly worked, so nice. This is the, let's make this a bit bigger. So well, we can draw I think we can do this row and rows 6, and well, actually let's get this information from the empty board, num rows and num columns. So let's multiply these, actually let's multiply here in the context. We should be able to access the bitmap, but it doesn't seem to be the case. But well, yeah, let's this is the columns and rows, and so here we can use the bitmap width and bitmap height. So let's row in until number of rows call number of calls, and let's draw this blue instead, and here we can multiply this is the x that columns per 64, and the same for the row, something like this, and we have the skeleton of the game, which is great. So we have done this programmatically, so nice. Yeah, we have an empty chip, red chip, yellow chip, nice. So let's we should put the skeleton above everything else, and we should have a container with the chips in here. So let's create here a container, an empty one, and let me create let me create maybe a solid rectangle that is transparent initially, that has the width of the chip, and the height is the 64 per number of rows, and let me create one per columns, and place it 64 per n. Let me place them there so you can see with alpha double. Let me make this semi-transparent so you can see. If I put an on click here, I have the n, I can click on all the columns and know which one I'm going to drop the check in which one I'm going to drop this. So let me alpha 0.0, and when we are over here, let's update column indicator. So when we are over this column, let's adjust its alpha so it's visible, and when it's out, let's remove this alpha so we can see here this is not working. Let's adjust it like this. So we can see maybe not with red but with white or something like that. So we can see in which column are we going to click. Sorry. And when we perform the click, let me create a function here to actually drop a chip in a column, and well, let's see, let's drop for now red in the column specified here. So launch immediately. So here we are going to update our boat. Where is our boat? We don't have it anymore. Board empty. Let's update it by applying an operation of placing this chip in this column. So result. So if this result is not null, let's get the new board and let's iterate over all the actions these placement has for us. So here we can check all the branches here and here we can perform some things. I'm going to use the animate functionality. So here I can create let me create a chip here that actually it's an image in a column and a row. So let me get the position of a column and a row here, a point, which will be this column multiplied by 64, and here the row multiplied by 64 too. So here we can create an image in this container with the chip type. Let's create a map, chip images. Let's create a map of, for example, chip empty to empty chip, and do the same with yellow and yellow chip and red chip. So we have the chip images here, and we can create an image with this chip. Let's force this. We are going to put it with centered, and we are going to place this in this position. Let's add here 32, since this is going to be centered and column and row. So something like this is creating and placing the chip in this container. So for now we are going to create the chip in this column, but outside the boat itself, with the chip they provide us. And I'm going to move this to its actual position. That will be this one, action column and action row, and the chip placed is this one, and I'm going to move this to this position. Maybe I can provide a specific speed of pixels, like 2 cells per second. So something like this, and this is working already. The bad thing here is that, well, I probably should wait for this to complete. In fact, what we can do is to create here an asynchronous thread that allows us to query some operations. So instead of executing this immediately, we are going to query them. So if we press several times, the chips are not thrown immediately, but one by one. So, well, also we should here, or well, let's not do this now so we can go quicker. So in every turn, every time we perform a drop, the turn changes. So let's create a variable called turn. So here, this is the turn of red, and let's, since this is suspending, let all turn equal a turn, and let's change, if the turn is red, let's change it to yellow, and the opposite like this. So this is the new turn and this is the current turn. So new turn. So here, before we wait for this to happen, since we are not queuing, we are changing the turn here. So yeah, and now let's try to throw an exception here, and let's not change the turn, so we can check the finish easier. So here you can see this has been thrown. So maybe we want to execute first the drop, and later maybe we want to execute the other things. So let's move the animation here inside this, and let's only perform here the drops operations, or maybe we can, yeah, let's keep it like this, but let's split this into actions, or maybe instead of a list of actions, let's split this in two lists annotated, so we can execute a list of actions in parallel, and the other ones, and for each list here in so the ones in this list in parallel, and each list sequentially. So here now this is actions. Let's rename this to actions lists. So now this is a set of actions, and we can iterate over this, and here we can put a node for the animation that executes these ones in parallel but all these sequentially as a sequence. So now these ones will be executed in parallel, and we have two lists, so the drop will be executed first in the first list, and the finish will be executed later in after this drop animation. So well, we should have an array or something with keeping information about the views in this board, in addition to, let's create an array 2 of number of columns and number of rows with view information. So generate initially null. This can't not be null. What a pity. So any, for example, or well, let's create empty views here. So we have a map of views here, and we can place this chip here. We can place it in this returns, this not returns the view. So let's move, well, let's split into the chip view here, and let's perform this operation, and we are going to store that view in the right column and the right row and the right row. So this is the column and this is the row. So here we have now we can access the chips here. So well, now we can iterate over the positions that win. Let's rename these two positions. By the way, the test probably broke, since no, they didn't, because I was not checking the actions. So well, I can iterate over the positions here, so I can get the view at this position. Views and position column, position row. So I can access this view and do something like, I don't know, maybe adjust, for now, adjust its opacity to 0.5, or I don't know, or making tinting, maybe adjusting its color transform. So making white, for example. I hope this works, but I don't know if I have to set, yeah, I probably have to set this like something like this, but well, this happens at the moment. So instead of doing that, let's execute or let's twin chip view twin. Let's create a color transform here with alpha. This is this interpolable? This is interpolable. So adding this is something called color add here. So I think here I can put something like this, and view color add. Maybe I can set this to we should probably change this in KorGE 2.0. But well, I think maybe I can interpolate this. So let's get this view and let's twin this color add property to this. Not like this, like this. No, but not this one. Here, not the view. So maybe we can execute this block. Wait, twin. Well, instead of doing this, it's like this. And here what I have to specify here, this is optional, so I think it should be like this. Yeah, this is not I can't do this because we have I can't do that because there is ambiguity. So how can I resolve this ambiguity? Maybe with this. This is one and this is the another. Time this time. Yeah, like this. Well, we should probably work on this, but well, let's try this and let's see what happens. I don't know if this will work. Yeah, it didn't work right because interpolating this is not right. You can't interpolate an integral like this. So we should do something like this. But in the end, here the game has been completed. So yeah, here before doing anything else, maybe we should perform the operation in other place, but well, we should we should finish the game probably after that. So let's see. Well, let's try first if this works with two kind of chips. So something like this. Now yellow. Maybe we can set the color to the current tune. So colors red here and colors yellow here, so you know which chip is going to be placed. So update indicator color. So something like this. We should update it after we change the tune also. So, but yeah, I think this changes the color, but we should use the same alpha. The same alpha we had already. So something like this, and well, now we can try to win a game, yeah, like this. And after that, maybe we should press, after pressing again, the game should start anew. So game finished, and if the result, maybe here, because here nothing has been executed, here we can set the game to finished. Probably we shouldn't do this. We should probably check the new word here, the result board, and probably outside any suspending, so this is synchronous, and board is winner if the winner if this is not null, the game has finished. So when the game has finished, and we click again, I think the first time we shouldn't do anything here, but actually we could do this with themes and other features. I'm doing this in line so you can see how to do this, but probably you should use scenes and other things. But well, here we should restore the initial state, so the board is empty, and we should remove all the views in this container, clear or remove children. So the game starts again, and let's do nothing. Then maybe we can create an overlay that they have to, when the game finished, so they have to press or switch to another scene or something. But for now, let's do this. So when we press anywhere here, the board starts over. And we should probably only enable I think, yeah, like this. I think we should probably only enable these visual indicators when there are when this movement is possible. So maybe here we can try to put to get the current board and try to apply a placement operations here with any chip, maybe the one in this turn and this column. Let's rename this to column, and if this is not null, then we can provide this indicator here. So for example, if this is full, no indicator here. So let me do this. I think now, since the game has been win, now when the game has finished, we should, for example, when the board has a winner, maybe we can remove this indicator too. When it's null, we have the indicator. So something like this, and now no indicator, but we can click and start over. So well, something like this, and I think I have finished. It has taken 1 hour and 56 minutes. This was the first time I did this, so I had to figure out some things, but maybe the next time I can do this quicker. So well, let's finish this video. Thank you for watching and see you in the next video.